Hello, I'm Tom Hollingsworth, and welcome to Networking Field Day. We are here in Palo Alto, California, with our friends from Apstra. We are going to be listening in about their new product and solution, and we have around the table a group of Networking Field Day delegates. They represent the best and brightest podcasters, speakers, writers, and influencers in the community. They are going to be asking questions, making comments, and offering their opinions as part of an invited panel. If you would like to learn more about this event, including how to become one of these delegates or a presenter, please go to our website at techfieldday.com. You can also find more videos like this about a variety of technical subjects at our YouTube channel, which is at youtube.com/techfieldday.
All right. So again, we haven't deployed anything yet because we wanted to make sure our physical layer and our cabling was okay. And so now I could deploy this configuration. And it says I'm going to deploy these 4 switches, and I say, OK, do that. And now what we see is that it's in the process of taking all the configs that we generated, pushing them to the devices, applying them, and if there was any kind of, for example, let's say you're doing port transformations, that would be happening here. They'd be putting the ports in different speeds and whatnots. But you can see all of the things that we're checking, or all of the expectations that we have as a result of this design. So again, as a network engineer, you do this. You go, I'm going to show this, I'm going to show that, I'm going to check this. You have some mop that somebody wrote that said, here's my standard mop. So for every BGP neighbor that you have, repeat this command, and then check that off. And that mop is like 20 pages. And you have to do it manually. And if you do it at 2 in the morning, right, that's what AOS is doing for you right now, all of that. It built the mop for you. It ran the mop for you. It told you the mop is good. OK. So as that's being deployed, one of the things that we have to do, which is kind of fun and interesting, is, well, you can see that my BGP to my external router isn't up. Well, that's because I haven't provisioned it, right? Let's say this is pretty classical, right? The WAN guys haven't provisioned it yet. So the blueprint information that AOS provides you has a whole bunch of data in it. And I'm gonna extract that data. Like, for example, part of that data is if I wanted to look at all the server links, right? These are all the IP addresses that are associated to the servers. Well, what if you wanted to use DHCP to make this work? Well, I asked one of our customers, well, how do they do this? Because this was a really novel thing. And they said, well, what we end up doing is we have to create DHCP scopes for every point-to-point link. So when it boots up and it relays through, I see the subnet that it came off on, which was the leaf port IP address, and then it works. And I'm like, well, that sounds like a lot of work. Sounds like something we should automate, right? So we do. And so we take this data, we automate that process. And so I'm going to run again, an Ansible script that uses our modules to do this. I'm going to say Ansible playbook, and I'm going to say make infrastructure. So for me, infrastructure is the external router and my DHCP server. I'm going to say my blueprint name is, what did I call our blueprint? I called it rack together. So rack together. And I've written my playbook so that I can actually build and clean using the same playbooks. So I'm going to say build. So this is basically making my infrastructure for this blueprint, and I'm building. So what it's doing here is it's literally extracting the blueprint data, and then it's connecting to my external router. It's provisioning Quagga. It's doing something with the interfaces. It just restarted Quagga so that it takes effect. Now it took my DHCP scopes, and it built all my DHCP scopes, and it turned on and it started my DHCP server. So what this means is if I go to my telemetry, I should see that, lo and behold, my BGP neighbor is up. Right? That's good. I like to see that. OK. So I've got I have a deployed system. Now the next thing I want to do is boot up some servers. Right? If I look at my system, I can see that I've got my leafs and my spines, but I don't have any of these servers booted up yet. So I've picked some ports on these switches, and these servers are just virtual machines on my box. Each of them have a 10 gig port. So I'm going to start those up. So I've got 3 servers, Alpha, Bravo, and Charlie, and they're all the same. They're basically just going to DHCP, and they're going to get an IP address. And as soon as that happens, they're going to register with AOS because I have the device agent installed on them. I can see that if I go to this devices tab, and providing everything works, they should show up here in just a second. And you can see them here. And so they're showing up. And what's interesting is that their management IP address, these are the values that come from that blueprint, right? I could say, well, here's server 15, leaf 2. And if I went to this blueprint and I went to links, and I said, show me the links. And I said, show me server 15 on leaf 2. I can see that this is 219. And I can see that this is 219. I could have randomly picked any cable. I mean, because they all operate the same way. So I'm going to approve these devices. Now, when I approve these devices, something really interesting happens. AOS, since it knows the IP address of the management interface and it knows that it's bound to a particular blueprint, it automatically creates that association for us. So there's no mistaking, this problem. And when you have a lot of servers, it's an easy mistake to make. So if I go to the blueprint, and now I say, I have all of these nodes, and I'm only showing the spines and leaves, so let me show the servers. But I have a whole bunch of servers, so I want to filter the servers only by the state that are actually in a ready state. So these are the ones that are ready. That makes sense. I'm going to deploy them. And when I deploy these, what's really happening is we're configuring Quagga on those servers. All right, so we push this Quagga config. And you can see that we've got some BGP expectations on these leafs. And then we're going to start again to gather our LLDP. And then if we wanted to look at the system level topology, or like if we went at the system level topology, we can see that these servers are now under active management. So what does that really mean? If I were to log into any one of these servers and dump the routing table, you would see the BGP sessions communicated throughout the entire pod. And I'm going to show you that, because I like showing that. Cool. All right, so I'm going to go to leaf 2 because I happen to know that leaf 1 is connected to my router, and that doesn't make for a very interesting demo. So I'm going to go to server 2. So I'm going to SSH to that IP address. OK, so I'm on leaf 2 because I can see it in the host name. You guys can see that OK. And I'm going to use VTY SH because I'm using Quagga. And if I said show IP BGP summary, this tells me, I have a neighbor. I've got some prefixes. Maybe I'd like to look at what those prefixes are. And I can see all of the routes because I haven't constrained the routes through route maps. I can see all of the routes. And every single device in our blueprint has a unique ASN value. So I know exactly every hop by hop for every IP address, right? Which is pretty cool for troubleshooting and doing things that network engineers know how to do better than I do. If I do a trace route, say I want to do a trace route to my 1.1.1.1, which is my router, I can see from this output that I'm going through my leaf, through a spine, through another leaf, and out to my IP address. I know that I'm going through the topology as I would expect. And so there's a whole bunch of commands. As a network engineer, this might be really, really useful to do. But where this gets really interesting, and I'm just going to talk about the container thing, because this was mind-blowing. Like, we worked with a company that every container had its own IP address. Like, they found a way to do that. And recently, Docker made that available kind of to everybody. Like, they've added that capability. And so I actually did a demo at another conference where I had this up and running on my laptop. And I modeled with this design kind of the back-end containers and the front-end containers. And I spun a whole bunch of them up. And I used Docker Swarm, and it's really, really cool, to orchestrate the placement of those containers on the nodes. But what was really cool is every container had a /32 in the routing table in the pod, which meant I can use this ASN prefix to then correlate those IP addresses to where those containers were, meaning I could say on this leaf, I have 100 instances of a particular type of container. Like there's never been the ability to create that correlation between application load and network load before in this way. And this is just routing. This is like, let's keep our network simple. Let's use BGP and LLDP. And here's a way in which we can finally do something that we never had the ability to do, which was application load correlation to network load correlation. And using sophisticated technology to make that process capable to everybody else.